All right, thank you guys. Thanks for that welcome. Super excited to be here. So I'm just going to tell you, to start off, I'm just going to tell you a story. And this is a classic story of the GraphQL monolith. So here it is. You bring GraphQL into your company. It's a new technology. It's going to solve all of your problems. And it starts out very convenient. It's manageable. It has so much power and so much potential. It's beautiful. You probably have the whole schema memorized at this point. And you're so excited to get everybody on board. And then some time passes, and your graph starts to grow. It starts to mature. It's maybe not listening as well as it did in the beginning. It's a little bit more unpredictable. But maybe at this point you have a company-wide mandate to get everybody on the graph, and you're just ready to go full force ahead. So you keep going. And then one day, before you know it, you have a fully grown, out-of-control monolith. And this thing is just taking over your life. Your team is only concentrating on keeping this thing alive. They're getting paged for everything that's going wrong in every part of the graph. It is really a big problem. Not only that, it's probably causing reliability issues and developer experience issues. So you really need to do something about it. So what are you going to do? Well, luckily, you guys know the answer to this. It's time to federate. It's time to tame that beast. You need to break apart that graph. So luckily, there's tools out there to help you do this. You guys, this is really easy, okay? All you do is you put a router in front of your monolith, and now your monolith is your first subgraph. Then you make a copy of a part of your schema, put it into another repo, has its own deployable, and you flip a switch, and you're done. You've just decomposed your first subgraph out of a monolith. And everything is rainbows and unicorns. Okay, I can see that I'm not really fooling you. I think you guys know that whenever you see rainbows and unicorns on the screen, there's something that I'm not telling you. All right, so what if I told you in this scenario that downtime would cost you tens of thousands of dollars per minute? Not only that, it's going to cost you ongoing reputational damage. What if whenever your app goes down, there are financial blogs written about it? There's news articles. People post in social media. I mean, it's a big deal. Not only that, what if your traffic pattern is as unpredictable as the price of Bitcoin? I mean, that's a crazy graph, right? It goes up 1,000%, down 500%, up 300. I mean, it's insane. I mean, if you kind of blur your eyes a little bit, it does kind of have a little bit of a pattern to it, but anyway, not financial advice. Because of this, your traffic volume could 10x up or down within a matter of days. So if this was your scenario, you probably would decompose your monolith a little bit differently from everybody else. You'd want to do it carefully, a little more safely. So that's what I'm here to talk to you about today. So before we dive in, my name is Stephanie. I'm an engineering manager at Coinbase. And I've been a software engineer for a really long time, which means that I'm perfectly happy sitting in a dark room writing code all day long. But the longer that I went through my career and gained more experience and saw more of these larger companies, the more I realized that I actually enjoy taking a step back and looking at the bigger picture. I really enjoy communication, cross-team communication, communication upwards, and really organizing and thinking about the bigger picture and also helping other engineers with their career and their growth. And so that's why I transitioned to engineering manager. So right now at Coinbase, I manage a few teams within the infrastructure org. And one of my teams owns the GraphQL service. And within infra, our customers are the Coinbase engineers. So everything that we do is to make their lives easier. We want them to build things faster with more reliability, and we want them to have fun doing it. Okay, I also have a confession. I love migrations. I mean, it's probably a good thing, because all infra does is migrations, right? I mean, don't you just love it when your infra org tells you to migrate from one technology to another? And don't you love it even more when they got leadership to give you a mandate to say you have to do it? Well, I just love the coordination and the communication of those large-scale company migrations. So when I joined Coinbase about 3.5 years ago, we were just starting our migration from REST to GraphQL. Oh my goodness, sign me up. So before too long, I actually was DRI for the whole thing, and it ended up being a multi-year, massive effort. But we finally did it, 100% from REST to GraphQL. And since then, as you could expect, we have grown our very own, out-of-control GraphQL monolith. Literally, that is the name of our repo. So we were thinking ahead, I guess. So for us, the point when we realized that we were ready to federate, I think we kind of always knew that we needed to, but we got to a point, we needed to get to a point where the return on investment for federation was a convincing argument for leadership. And that's why we didn't start out with federation right away. And so now that we have this convincing argument, the graph is very big. It's having reliability issues, scalability issues, like we need to solve this problem. So it's time for another migration. All right, so just a quick roadmap in this talk. I'm going to talk about, so how do we decompose safely at scale? What are the tools that we use to accomplish this with confidence? And also talk about our self-service adoption strategy. Now that we have those tools, how do we get teams to actually federate? And finally, I'm going to talk about some learnings that we have had along the way. Now, we are in the beginning of our journey of decomposing the monolith, but we have learned a few things already that I will share with you. All right, so like I said before, we are a trading company, which means if our app isn't working, people aren't trading, and we're losing money. So every second of uptime counts. So how do we federate safely at scale? Just to give you an idea of the scale we're talking about, right now our monolith is about 7,000 fields, and to date we've had about 600 active contributors. The first subgraph that we targeted for decomp is our product called Coinbase One, and this subgraph serves about 1 billion operations per month, which is about 23,000 operations per minute. So we are using Apollo, so why can't we just use the override directive? Well, there's a couple problems with the override directive for our scenario. One, it is all or nothing. So as soon as you put an override directive on your fields, 100% of the traffic for those fields are going to be going to your newly created subgraph. Second problem for us is, so we use Kubernetes for deployment. We have a canary. But even with that, our deployments take about 15 to 20 minutes, which means that if something goes wrong in that process, then at minimum, we've lost about 500,000 operations before we can roll back. So that just wasn't going to work for us. And this is something that we realized in the beginning of our partnership talks with Apollo. And we just realized that this all or nothing approach to subgraph decomp is not something that is going to work for Coinbase. So in our talks, we actually suggested a feature, and Apollo built that for us. And so they built progressive overrides. But you guys get to use it too, don't worry. So what this does is it allows us to migrate a percentage of traffic at a time over to our new subgraphs that we're decomposing. So it's reducing the blast radius of potential downtime. So just to dive in on how it works, So this is the original override directive, and you put it on a field, and the router will resolve all the traffic to your subgraph. So with progressive overrides, you just add a label with a percent, and whatever percent you put into that label, only that percentage of traffic is going to be routed to your subgraph. And this is great. This is exactly what we wanted, and helped us feel more comfortable about decomposing at scale. But as we started to use it, we realized it was still not quite good enough, because we still had to wait for a schema deploy to change that percentage, because it's a directive, it's on the schema. And when you're talking about large quantities of traffic, even a small percentage can make a big difference. And so we actually took this implementation a step further. So we decided to define our percentages in our own internal config service that we are able to deploy within seconds. And we made use of the router coprocessors to implement this. So this diagram, you've probably seen it in the Apollo docs. This is a diagram of how the coprocessors work. So a coprocessor is really just a block of code that lives outside of the router, but you can inject that code into any lifecycle of the router. And you can either perform custom actions on your own systems, or you can even modify the request coming from your client, or you can modify the response coming from your subgraph and your router. So what we did is we used our coprocessor to hook into that config service and grab those override percentages and modify that query as it's coming into the router. And that means that we now are able to change the percentages on a deploy that just takes seconds. And the only thing that we have to deploy to the schema is just a label. Just a word of caution about the labels. So with the original override directive, there's one query plan for every operation. Now that the labels have been introduced, there's actually a query plan for every unique label. So you just want to be careful not to introduce too many unique labels into your schema so that you're not adding unnecessary latency to your router. So just use the same label for a whole batch of fields that you're migrating. Okay, so now that we have percentage-based traffic control and almost instant rollbacks, what else do we need? Well, we need really great observability. If something goes wrong, we want to know right away what part of the stage is going wrong and exactly what is happening so that we can diagnose and fix quickly. And so we use Datadog, and we pump a ton of metrics in here, and this is just an example of some of the things we have. The graph on the left just shows the percentage of traffic in the supergraph that is going to each subgraph. As you can see, we still have a long way to go. The one on the right is, it compares the latency of each subgraph. So we know if a subgraph gets a deployment that increases the latency, it spikes, something goes wrong, then we know exactly where that's coming from, and we know where to go to talk to the teams to get that fixed. We also have a subgraph dashboard template that we give to our subgraph owners to make sure that they are feeling very comfortable about how to diagnose their own issues and problems. Because before, these dashboards all belong to us, right? And we know how to use them, and we are in charge of them, and we diagnose. But now that we want our ownership to be extended to our subgraph owners, they need to be able to have all of the same information, and we don't want them to be building it themselves. So this gives them a lot of things, but things like how many responses, what their latency is, their error, their percent of traffic compared to the supergraph, error percent compared to the supergraph. It also tells them things like how their subgraph is affecting the mobile app, or how their subgraph is affecting the web. So a lot of good things in there. All right, so this is great. We have what we need to decompose safely. So everything is rainbows and unicorns. Okay, all right, you're right. There's something that I am not telling you. So now that we have all these things and we're confident we can do it in a safe way, how do we get teams to actually federate? This is the classic migration problem, right? Well, because it is the classic migration problem, you actually can use a lot of the same strategies that you use for any migration. And so there's a few things that we learned in our migration from REST to GraphQL, a lot of the same principles that we are going to be applying to our new migration. So the first thing is you need to make it easy. People say that all the time, make it easy. But how do you actually make it easy? Because these things are complex. Well, the way that we go about it is the first few migrations have to be white glove. We need the experts, which is our team, to be decomposing these subgraphs ourselves, because we want to be the ones who are discovering the pain points, and we want to be the ones that are discovering the edge cases, because we are not going to be nearly as frustrated as another team that we have released, and they find the problem, and then they're coming to us to figure out how to fix it. And then we can use that knowledge in those white glove migrations that we do to build tools, to abstract away those pain points, or abstract away the things that we don't want our customers to have to think about. Some of the tools that we have created at Coinbase, so we have what we call a new service maker. So this is just a really simple UI that people can come to build a new service. They enter in some information, and it does everything for them behind the scenes. They no longer have to go separately to GitHub or AWS resources or all the things that you needed to do to build your service. The next thing that we have provided is our subgraph CLI. So this is a CLI that you can run once you've created your new service, your new repo, and it sets up a lot of things for you. Like the schema formatter, it sets up the shape of your repo, it sets up your make files, again, so that our customers don't have to worry about putting all of that in themselves, and we can be confident that they're actually using a linter. So that's a good thing. And then we've also created a decomposition planner. Now this is something that we've developed in-house. It crawls the schema and basically gives you an idea of how complex a certain decomp is going to be. So it tells you the number of types, the number of back and forth cycles that you're going to have to deal with, how many entities you can be expected to make. So a lot of good information up front to give teams somewhere to start. All right, the second thing you need to do is show teams that your migration is valuable. So what do you think engineers deem the most valuable? It's their time. Really, why do so many engineers have $1,500 ultra-wide monitors? It's because somebody told them that it was going to save them 10 minutes a day, and so they went out and bought one. So if you want to get teams to federate, you need to show them how it's going to save them time. So we can entice them with things like faster CI times. Now, this one makes a lot of sense. Like if you are in a monolith environment and you have many, many resolvers and tests and things that you want to be checking in CI, it is going to take a long time. And the more that grows, the longer it's going to take. So if you federate into your own repo, your CI times are going to drop dramatically. Another thing is we're going to entice them with no more waiting on +1s from our team. If you are like us, we have a centralized schema governance team, and we +1 every single schema change that comes into the monolith. And that is something that other teams have to wait for. It slows down your velocity. The other thing that they will get by federating is continuous deploys. So right now we deploy our monolith once per day. And for Coinbase, like that is pretty slow. Like there's a lot of teams that want continuous deploy. They want to be building and iterating on their product a lot faster than that. And also, if you're deploying in a monolith with everybody else's changes, if some other team makes a mistake and we have to roll that back, then your change gets rolled back too. And the last thing is just faster local development. Same thing, if you're downloading an entire monolith code base locally and you're trying to build it and work with it, it is just going to take a lot longer. So that is a good reason to give teams a Federate, is that you have then a smaller, more manageable local environment. And really, at the end of the day, we want it to be their idea. We don't want to just tell them to go migrate. We want them to want to. So there are ways that we do that. We showcase the teams that have already done it, showcase those wins, those productivity gains. We spam Slack with their successes and their case studies and quotes that say how amazing their new experience is. We provide company-wide visibility on who has federated and who hasn't and who's in the lead, and you can even gamify it. You can give prizes. There's lots of ways to make it fun. At the end of the day, sometimes though, you do need a company-wide mandate, and that's okay. But there's a lot of things that you can do before you get to that point. So we're doing a lot of this right now, and like I said, we are in the beginning. We're currently in the thick of decomposing our monolith. We have a long road ahead of us. But we already have learned some things from when we started. So the first thing that we've learned is about scaling. So we assumed that the solution to our scaling issues is decomposing the monolith. And that's what we are doing. That's a part of what we are using, a tool we're using to fix being able to scale. But at the same time that we are decomposing this monolith, our company has separate initiatives to increase the scale of our entire systems. I mean, remember those graphs with the traffic? We want to be able to handle those huge spikes in traffic. And so our entire system includes the GraphQL monolith. So we have needed to focus on the health of the monolith at the same time that we're trying to focus on decomposing the monolith. And what we've realized is that we actually have the capability to scale our monolith way beyond what we thought we could. We've been fixing things like upstream latency handling and caching and service timeouts and DNS configurations. We've just been forced to deal with these issues because of these regular production load tests that we are going through to get to a certain scale. And we've actually been able to scale the monolith at this point to handle 2 million unique users per minute, which is really crazy. And so because of that confidence and really realizing that we can tame the beast to an extent, that's changed a bit what our subgraph landscape is going to look like. In the beginning, we were assuming, okay, we're going to decompose the monolith, and that's going to look like hundreds of subgraphs, right? We want a subgraph for every service. But as we think about that more and talk to other companies that have supergraph ecosystems, we realize that that isn't exactly what we want. Like we actually want to have a smaller number of subgraphs, and some of those subgraphs might be mini monoliths. And now that we know that we can handle the mini monoliths to an extent, but we also want to take advantage of the federation architecture, we can try to get the best of both worlds. Because if you have too many subgraphs, you are introducing a whole nother set of problems, right? You actually have social, economical, or technical problems where when you try to make a change, you have to make it across too many repos, and maybe all of them have different versions of a library that needs to be unified, or you need to make multiple deploys for one feature, or you're increasing your latency because now your function calls are all gRPC calls, or there's lots of of reasons not to be overextended. And so we are looking at a division more towards not necessarily service, but more towards org or product divisions in our graph. And I think that is going to serve our needs a lot better now that we have the tools and the confidence to be able to do both. And so finally, some of our North Stars. So we want, at the end of the day, we want our super graph ecosystem to be reliable and performant. We want it to be easy to use and easy to understand. And we want to get from here to there in a safe way that we can be confident that we are doing everything to the best of our ability to maintain that priority. So if this talk resonated with you, go ahead and check out this panel later today on building a thriving supergraph ecosystem. You can hear a little more in detail about building this type of ecosystem, what kind of challenges there are. And if you have any questions, come find me. I would love to talk more with you. So thank you very much.